So the first question is to use the pipe to measure the pressure at the point A. So we know some height. So we know some difference of height, and the dark fluid is water, and the bright one is mercury. And we also know the density of water and also the specific gravity of mercury. So based on the known properties, we could get raw water is 1000 and raw mercury is 13.56 raw water, right? So we want to know the pressure A here. So firstly, we start from left to right. So what is pressure A? Pressure A is the pressure A plus rho W GH1, the height difference here, the height here, we could get pressure B, the pressure at point B. And because it is linked and continuous, so the pressure B is also equal to pressure B prime, which is, so the pressure B prime here is equal to the pressure C plus rho mercury GH2. The H2 is a height here, which is 30 centimeters. Yeah. So for PC, we want to know the PC as well. So PC, the pressure C, is pressure C double prime. It's the pressure here, because it is linked with air, and the density of air is too small relative to comparing with the water and mercury. So we just assume that the pressure does not change in this continuous air. So we got PC double prime is PD plus rho W GH3, right? So what is PD? It is linked to the atmosphere, so it is also P atmosphere plus rho W GH3. So we can just use this equation, these two, put that into the equation 1, we got PA is P atmosphere plus rho W GH3 plus rho mercury GH2 and minus rho water GH1. So you just need to put all the height into this one, and we can get the final pressure, which is P atmosphere plus 35.5 thousand power. So we got the final, the pressure. We got the pressure in gauge. Because we don't know the atmosphere pressure, we just write the terms in gauge pressure. We got the final pressure here. Any questions? Okay, and you got this solution of this tutorial after the session on Blackboard. So if no question, we just go to the second one. And 2 minutes to read it. So it wants us to get the gauge pressure at the bottom of this tank. But what difference is that the density of the water in the tank varies with depth. So it, according to the equation, so if the density changes with depth, how we solve the problem? Yeah, do the integration. So the fundamental form of the hydrostatic equation, we got, so we suppose that one is the y-axis. So because the rho changes following this equation, so we can got partial p over partial y is rho g, right? Then we got the pressure over the depth. We got the relationship here. So we can got delta p. We do the integration from 0 to the depth. The depth we note it as L. is rho g dy. Right? So we just put that equations in. And we got so which is 1000 G L plus a square. Sorry. So for it's 1 meter, we can get the P as 10.8 thousand pounds. So if the density change with depth, we do the integration to get the pressure at typical depth. Any questions? Does that make sense? So we just move to the next. So an inclined manometer is filled with the fluid, the oil of specific gravity, 0.85, and it is initially linked to the atmosphere, and then the pressure line is then connected that creates a gauge pressure of 500. So the level of it. Oh, it's too big. So the level of it increased by the H. And it got the depth, it got the length of D is equal to 200 millimeters. And we know the diameter of the pipe, and we want to determine the inclined angle alpha here. So firstly, we could use the specific gravity to get the density here, which is rho equal to 0.85 multiplied by 1000. Right. And then we know the diameter and also the length of D here, the change of the fluid in the pipe. So firstly, we know the dotted line is the initial surface, and then the surface in the tank just going down, and the surface of the fluid in the pipe just raise up. So we can use we can get the surface, we can get the pressure at the initial surface. We noted it as B. So the PB, the pressure B is what? Is atmosphere pressure plus rho GH. Rho GH. H is D sine alpha here. Right? And then we know that PC at this surface, we know the PC is equal to PB, the initial surface. It has the delta H here. So the PC is PB plus rho G delta H, which is P atmosphere plus rho G D sine alpha plus rho G delta H. So we know the relationship of the pressure at the surface C and the surface B. So we know the cross-sectional area of the pipe. We know the cross-sectional area of the pipe is pi over 4 multiply square, right? And also we know the diameter. We know the diameter of the tank. So we can also get the cross-sectional area here, which is okay. But then we still need one equation to make these equations close. Anyone got idea? Which one we used? So we know that the volume of the water, the volume of the oil here changes to the volume of volumes of oil here. So the volumes of these two areas are the same, right? Because it moves to that. So we just use the volume change in the tank is equal to the volume change in the pipe. So we got delta H multiplied by the cross-sectional area of the tank is equal to A D. We just know the length of the D here, the length here, and we know the cross-sectional area. We can get the link. So which is delta H is D, right? So we know the relationship here. We can get PC is equal to P atmosphere pressure plus rho GD sine alpha plus A over A capital, which is 500 plus P atmosphere. Yep, so we just take these two off and put the density and the length in the equation, and we got the inclined angle alpha at 2.85 degrees. Is it clear? Make sense? Got any question? So if no question, we just move to the next one. And if you have questions, you can ask me after the session. And for this question, I will give you like 5 minutes to solve it, 5 to 10 minutes to solve it. And you can communicate with each other about how you solve the problems. And so if you have done this, you can go into the next question on your tutorial sheet. No need to wait. So when we put the so before the pressure increased, we could get the before increase, we could get P atmosphere plus rho GH is 150,000 par, right? And we also know P atmosphere is 1 bar, so it's 100,000 par. So we can easily get rho GH is equal to 150 minus 100, 50,000 par. It is the case before increase the pressure, but after it gets a new H. So we got atmosphere plus rho GH new is equal to, so the pressure is increased by 50%, so it is 1.5 multiply 150,000 par. So we can get 100 as rho GH new is equal to 1.5 K par. So you've got equation 1, equation 2, equation 3. So we minus equation 3 is equation 1. You can just got the rho GH new minus H, which is 75,000 par. So this is equation 4. So we divide it, so put equation 4 over equation 2. We can got H new minus H over H is 75 over 50, which is 150. So questions? Okay, so we go to the next one. That one might be a little complex, and I will give you 10 minutes to solve it. So it says that the dam ABC is 40 meters wide into the paper. So the actual shape is like this. So you got the 2D version. You got the 2D version of this from this side. Actually have 40 meters into the water, into the paper, sorry. So from this, we know that the width of the dam is 40 meters and the water density is 1000, and also the atmosphere is 100 kPa. So we want to solve the force on the surface AB, that surface. So actually, the force on the surface might be caused by two terms. One is caused by the water, the pressure from water, and one is caused by the pressure from the atmosphere. Yeah, so actually F is equal to F air plus F water. So we know the depth. We just take an infinite part of the area here, which we take the length of it is dl, and make shadows here, dh, and we take the depth of it, h, and also the length of it, l. Right? So we know that at that point we can get the pressure P here at that point is rho g h. Right? So in that infinite part, we can just calculate the force caused by the water dF on that infinite part, which is vertical to the surface, right? dFW. It is equal to the pressure rho GH and multiply the area, which is the width W and also the depth, the length dl, right? It is the force caused by the water. So we know the relationship of AC is 80, BC is 60. So we know AB is 100 meters. So we can easily get the relationship between H and L. The H is here, the depth, and L is the length from A to the 0. So, which is 0.8, right? So we can easily get dFW, which is 0.8 rho G rho GW L dl. Right? This is the force on this element. So we do the integration from A to B, which to the whole surface, we can solve the force on the whole surface F water, which is from 0 to 100.8 rho GW LdL. So we got 9.81 multiply 40 multiply half L square from 0 to 100, right? So we do the integration. Here is 0.800 multiply 100 square minus 0, and finally got 1.57 here. So we could do the integration and to calculate the force. Yeah?
Today 1.97.
No, not 97. It's 57, because it is just the force by the water. And then we just add because we know the force by the water now, we also need to add the force from the air, from the atmosphere. So we add these two, and finally got F plus F water, which is how to calculate air. P atmosphere, which is, and multiply this. This is the force by the air, and plus 1.57. So we finally got 1.97. We finally got the force here, right? Okay, that one gives us one solution. Also, we could just do the force for the water, force caused by the water. We could decompose it to the two components. So one is water here. So the vertical one, and also the horizontal one. So for the horizontal one, we do the integration as what I did, similar to what I did. And for the vertical one, it is caused by the weight of the water. Just caused by the weight of the water. So we know the vertical force is the gravity of water above the surface. And we combine these two forces to get the force by the water, and then add it with the air. This is one solution. And also, for the water, we calculate the water force. We can also calculate the water force. The force is force on the gravity center of the surface, AB. So we just need to calculate the average force on this point, on the gravity center. Here, we know it is the half height, and we use rho gh to get the pressure, and then multiply it with the surface of the area, and then we can also get the hydraulic force, and then add it with force by the air. Make sense? So it's